Let's talk about the basic ingredients you need to construct a graphic using ggplot2. The four main components are a data frame containing your data. ggplot2 works with data frames. It doesn't work well with other structures. So make sure your data are stored in a data frame. When you construct this data frame, you should make sure that the data are tidy, which means that each column is a variable and each row is an observation for your data set. Second, we need a ggplot2 object, which is initialized using the ggplot2 function. Thirdly, we need a geometric object. These are called geoms for short. Geoms indicate the geometric object that's going to be used to visualize the data. For example, points, lines, polygons, etc. More generally, geoms indicate the type of plot that is desired. For example, a histogram, a density plot, a box plot, or something else, which aren't exactly a simple geometric argument. Lastly, you also need an aesthetic mapping. An aesthetic mapping indicates what role each variable is going to play in your plot. For example, it will describe which variable will play the x variable in the plot, the y variable in the plot, will control the color of the observations, etc. In their book R for Data Science, Wickham and Grollman provide the following template for creating graphics using ggplot2. We have ggplot. This is a ggplot object we talked about earlier. The data argument is where you specify your data frame, plus geom function. So this is where you specify your geometric object. And then you have the aesthetic mapping right here. So mapping equals AES mapping. So this is where you provide the mapping of the different aesthetics. And the data, geom function, and mappings, these are just placeholders that you're going to replace with your actual data frame, your actual geometric object, and your actual aesthetic mapping that you want to use in your specific plot. So let's just briefly describe, or let's briefly explain this template above. Every ggplot is going to start with a call to the ggplot function. That's what we have right here. You can actually create a blank plot by simply running ggplot open and close parentheses in the console, but that's not going to be very useful. In order to make your ggplot useful, you're going to have to pass your data to the ggplot object. Typically, you pass your data frame to the ggplot object through the data argument. This is the most common way of starting your ggplot. Alternatively, you can actually pass your data inside your geom function. But typically you only do that when you intend to use multiple geometric objects with different data sources, which is not that common for basic data visualization. The geom function indicates the geometric object that you want to use in your plot. The mappings describes the aesthetic mappings you want to use for this particular geometry. And one of the reasons that ggplot2 is really powerful is that you can use different mappings for different geometric objects. So you can have a mapping with one geom function, and then you can layer another geom function with a different set of mappings. And lastly, we have this plus symbol here. This is actually very important. The plus symbol is used to add a layer to your ggplot2 graphic. Make sure that if your code spans multiple lines, that all but the last line end with the plus operator in order to stack the layers properly. If for some reason your line doesn't end with a plus, then the R console will get confused and not know what kind of plot to create. Let's briefly look at some of the geometric objects that you can use in R. A complete list may be found currently by following this web link right here. We're only going to provide a partial list of the geometric objects that I frequently use. In the table shown on the screen, for each geometry listed, I provide the general data dimensionality that you use with that geometry, and also the purpose of that particular geometry. Geom_bar is typically constructed using a single variable and is used to draw a bar chart. Geom_density is also typically used with a single variable and is used to draw a density plot. Geom_histogram is typically used for a single variable and is used to draw a histogram. Geom_boxplot only requires a single variable to be specified and also draws a box plot. Geom_violin only requires a single variable and is used to draw a violin plot, which may be unknown to you, and we'll talk about that shortly. Geom_QQ only requires a single variable and is used to draw a quantile plot. The next set of plots discussed all require at least two variables. Geom_point requires two variables and draws points and is typically used to construct scatter plots. Geom_path and geom_line also require two variables and connects the observations in a scatter plot. So this is a geometry that you would use for line plots. Geom underscore segment requires two different variables to specify the coordinates and is used to draw straight lines between points, whereas geom underscore curve is similar but draws curved lines between the points. Geom underscore smooth is a helpful geometry that requires at least two variables and used to draw a smooth fitted model of the data in your graphic. Geom underscore density 2D and geom underscore density 2D filled require two variables and will construct the two-dimensional density plot for those two variables. The first draws contours of the density estimate, while the second draws contours of the density estimate with associated colors. Geom underscore contour and geom underscore contour filled will construct two-dimensional contours of three-dimensional data. You actually need three variables to construct graphics using these geometries. The first one only provides the contours, while the second one provides a filled contour plot showing the colors between the different contours. Some additional useful geometries are geom underscore AB line, geom underscore H line, and geom underscore V line, which draw diagonal, horizontal, and vertical lines on the current graphic and don't require the variables in your data to be specified, but do have certain arguments that must be specified in order to create the drawing. As we conclude this video, let's talk a little bit about some common aesthetic mappings. I want to point out that aesthetic mappings are unique to each particular geom. However, many of the same mappings show up in different geoms, and so we'll talk about them in general. So the X aesthetic controls the X variable in your plot. The Y aesthetic controls the Y variable in your plot. The alpha aesthetic controls the transparency of an object. So you can use this to create objects that are semi-transparent and you can actually see through the data behind them. The color aesthetic controls the color or colors of your object. The fill aesthetic controls the color of the interior of an object, which sometimes works differently than the color aesthetic. The group aesthetic controls how the data are grouped. The line type aesthetic controls the type of line used to draw the object. So this is usually most important in things like density plots or line plots. The size aesthetic controls the size of the drawn object. And then the shape aesthetic controls the shape of the object produced. This is more important when you're drawing points in your plot, for example, a scatter plot, where you want to distinguish different groups by different shapes.